All right, welcome back. We are moving on to the third lesson in this unit, and this really is just the continuation of what we did last time. We're going to be continue to look at permutations. However, today or last time we look at permutations with different objects. Today we're going to be looking at permutations with identical objects. Okay, so what I mean by that is, well, you'll see in these three warm-up questions. Okay. So here it is. It says list the number of ways to arrange the words dear, dear, and deed. Okay, so for the first one, that one is easy. These four letters are all different, so hopefully by now you know what we need to do here is just simply 4 factorial. Okay, 24. Again, if you don't remember, you have 4 different letters to choose from for the first placeholder, 3, 2, and 1, and so on, and therefore it's 4 times 3 times 2 times 1. Okay, now for the word dear, I'm actually going to list them all out. Okay, so this is going to be, it'll take quite a bit of space. Now before I start, I'm going to actually change dear to D, E1, E2, and R, just to show the difference between these two E's, because otherwise they're the same E's, right? So what's the difference, right? So I'm going to write up D, E1, E2, R. Okay, so the first way to arrange it obviously would be D, E1, E2, R. And then we could write this as D, E2, E1, R. Notice how without the 1 and 2, they really are the same thing. But if you separate them into E1, E2, then they are actually 2 of them. Okay, I'll show you one more, and I'll let you try to list out the rest. Okay, so we could have we could just switch the R and D, so then it could be R, E1, E2, D, R, E2, E1, D. Again, this would be a pair, right? But these two will be the same thing. Okay, so I'll let you try to list out the rest. Okay, so good luck. Okay, so if you list them out, this should be the total, right? This should be all of them. There will be 24 of these, right? I mean, as we expected, because there are 24, right? Arrangements for 4 letters. However, because we have 2 repeated letters, really we should just have half of it, because D E1 E2 R is the same thing as D E2 E1 R, right? So for every single D E R, they are actually for every 2, D E R, it's just 1, right? So so really the total should be 24 divided by 2, which is 12, right? Because there are 12 repeated ones. Okay, oh, interesting. We divided by 2. Okay, so we need to think about, oh, where is this 2 coming from? Because 24, we know where that comes from. That's just 4 factorial. Now, where does this 2 come from? Is this 2 because there are two letters? So in this case, what do we do then for the word deed? Because then, do I divide it by 4? I don't know. Let's see, okay? So it turns out, well, let's check, okay? So again, I'm going to, instead of DED, I'm going to call this D1, E1, E2, D2. Okay, and let's try to arrange a deed in this orientation only, actually. So let's see. Okay, I can arrange this as D1, E1, E2, D2, obviously. I can switch the E's, so then I have D1, E2, E1, D2. Or I can switch the D's. Okay, so then I have D2, E1, E2, D1, or D1, D2, E2, E1, and then D1. Okay, so that's all the ways you can arrange the word deed using DEED. Okay, now notice you have 4 of these. So for every single deed, I guess there are 4 different ways to arrange them. So in this case, I think you probably guessed it, we would then take 24 and then divide it by 4, because for each 4, it really is just one single orientation, right? Just single one arrangement. So there will be 6. So then again, where does this 4 come from? Well, it turns out this 4 comes from, well, we have 2 pairs of the 2 same letters. So this 4 came from 2 factorial times 2 factorial. Okay, because we have 2 ways to arrange 2 E's and 2 ways to arrange 2 D's. So it's going to be less. So then we just need to divide. So that kind of makes sense actually. Okay. So in summary, the number of permutations of an object with r identical objects is simply n factorial divided by r factorial. Now, if we have more than one single identical objects, then we just keep dividing. Okay, and I'll show you the. I mean, you can see the formula is down here, right? In the set of n objects with n1 objects of one kind and 2 objects of another kind and 3 objects of another kind and so on, the number of permutations is simply going to be n factorial divided by n1 factorial, n2 factorial, and n3 factorial, so on. Okay, so here's the example. It says there are 7 boxes of cereals on the shelf. 5 of the boxes are brand cereal. So then again, we have total of 7, 5 of which are brand cereal. 1 is a puffed wheat. So I mean, if you want, you can put 1 factorial. You don't have to because it really doesn't do anything. And 1 granola, right? So then how many boxes can be arranged in a row? Then this is going to be 7 times 6 times 5 factorial divided by 5 factorial, which is going to be 42. Okay, so there you go. There's the practice question for you to try. Good luck. Okay, hopefully this isn't too difficult for you. We have 3 pre-calc 12 books and 4 identical novels. We want to put them in a row. How many ways can we arrange them? Well, there are 7 books in total, 3 of which are pre-calc 12, and then 4 are identical novels. So this is going to be 7 times 6 times 5 times 4 factorial, but that's going to cancel out with the 4 factorial, so I'm not going to write that out. 3 factorial is 3 times 2. That's 6. Cancel with 6. We have 35 ways. Okay? So really, just, it's very similar to what we did last time. We just need to add this little piece to it. Okay? All right. Here's the second example. Let me just tell you this, okay? So this unit, I feel that, if you do it section by section, it's actually quite simple. It gets quite tricky when you combine everything together. Then you need to decide, okay, which method do I need to use, and does this order matters or not, right? Because so far everything that we've done, order is important. Next lesson I will be dealing with is the one that order does not matter. Okay, and then how do we differentiate, right? Anyways, we'll get to that later on. For now, let's just focus on what we're doing today. Okay, so here's example number 2. Steve walks 13 blocks from his home to the library. He always walks 9 blocks east and then 4 blocks south. How many ways can Steve walk to the library? Okay, so this question sounds kind of, I don't know what to do. But really, if you simplify this question, it really is same thing as this. How many ways can you arrange 13 letters? And what are these 13 letters? Well, it's going to be 9 E's, right? Because 9 blocks east, 5, 6, 7, 8, 9, and then 4 S's, right? Because 4 blocks south. So we want to figure out how many ways we can arrange these 13 letters. Well, there are 13 letters in total, 9 of which are east and 4 of which are south. Okay. You can put this into calculator. Again, you can use the factorial symbol in your calculator. You should get 715. Okay, so there are 2 practice questions for you to try, and actually 3. Practice 4 though is, some of them are actually quite tricky, but anyways, you should be able to do the first 2 at least. Practice 2 and 3. Okay, good luck. Okay, practice 2. Naval signals are made by arranging colored flags in vertical line. They are read from top to bottom. Okay, and there are 6 flags, right? Namely 3 red, 1 green, and 2 blue. So 6 flags in total, 3 red and 2 blue. So if you put this into a calculator, 60 different ways. Okay, 1 green, I mean, again, for 1 green, you could put 1 factorial down there if you wanted to, but it doesn't really change anything. Okay, number 3, a kebab recipe requires 2 mushroom, 2 shrimp, 2 cherry tomatoes, and 2 zucchini slices. How many ways can we arrange them on a skewer? Okay, we have 8 ingredients, I guess. 2 mushroom, 2 shrimp, 2 cherry tomatoes, and 2 zucchini. You'd be surprised, actually. I was totally surprised by how many there could be, actually, if you put this into a calculator. There's 2,520 different ways you can uh, put 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 together these skewers. Crazy, actually. Okay, that's a lot. Okay, um, number 4. Okay, how many arrangements of the word poppies can be made under the each of the following conditions? Part A, no restrictions. Okay, so we have how many letters? We have 7 letters. We have 3 p's. Okay, so for no restrictions, it's simply going to be 7 factorial divided by 3 factorial, because again, we have 3 p's. Okay, so repeated letters. If you put this into calculator, 840. Okay, part B, it has to begin with a P. In that case, the first letter has to be P. Okay, so there's only one choice. Now you have 6 letters left. So we have 6 letters left, and we still have 2 p's left. Okay, so it's going to be 6 factorial divided by 2 factorial. This first letter P is just 1, right? Because we don't have any choices. Okay, if you put this into calculator, I believe you should get 360. Okay. Part C, the first 2 letters are P's. Well, that means it has to be P, and then P, and then we have 5 letters left. And now they're all different. So then it's just going to be 1 times 1 times 5 factorial. Right? Because the first 2 letters are all P's. You shouldn't say that there are 3 choices for P and 2 choices for P, because they're all just P's. Okay. If you put this into calculator, it's 120. Okay, part D, if all p's are to be put together. Okay, so what you need to do is you need to treat the 3 p's as a big P. Okay, as a big P. So what I mean by that is this: you treat them like one block of p's, and then you have the O, I, E, and S. Okay, like this. So okay, so in this case, if you put all the p's together, then really you treat them as a big P, so you just have 5 letters. You can think of it that way. Okay, and then what if in that case you have 5 letters and they're all different, so then this is just going to be 5 factorial, which is also 120. Okay, yeah, that's it. If you have any questions, let me know. Otherwise, there are some practice questions for you to do. Good luck.